All right, the majority of our content here in Chapter 10 revolves around various types of formulas that come up with trig functions. Today we're focusing on the sum and difference formulas for sine and cosine. You have a sheet with all of them on them, which would be very, very useful to have. In fact, if you don't, to be honest with this particular lesson, I wouldn't proceed any further until you know for certain that you have that sheet. Of course, the formulas are in your book under Lesson 10, Section 1, but if you don't have access to those formulas, because I'm going to refer to them, I'm not going to pull up a sheet here. I'll draw up some of them, but not all of them. Make sure you have that. Here's the idea of what we're trying to do is whether it's these particular angles or the reference angles, 30, 45, and 60 are significant because they represent kind of the basis of exact sine and cosine values. And what we're trying to do is to expand the number of angles that we could get exact values for. Okay, that's, at the end of the day, really what we're after. And these formulas allow us to do that. Here's the kind of problem we want to take on. What's the exact sine value of 15 degrees? Up until this point, all we'd be able to say is sine of 15 punched into the calculator, and we'd have to get a decimal approximation. But what kind of sets this apart is exact. Okay, now the first thing we want to look at is there any way, remember the angles we should really be thinking about are key points on the unit circle. And in the future, the problems we'll look at will kind of expand to any angle on the unit circle. But right now, just to keep it simple, because we're new at these, think 45 degrees, 60 degrees, and 30 degrees. Is there any way I could rewrite 15 degrees as a sum or a difference of those two angles? And hopefully you'll look at those and think, yeah, there's plenty of ways that you could. How about right off the bat, 45 degrees minus 30? Perfect. Okay? So I could take the sine of 15 and rewrite it as the sine of 45 minus 30. Okay? Now the formula that we're referring to uses alpha and beta. Okay, and I'll give you our first look at one of those. I'm saying 45 degrees is alpha, 30 is beta. The sine value of the difference of two angles, okay, is equal to sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. Okay, that's the sine difference formula. Okay, now if I were to proceed with the numbers that I had, what this would then say is the sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. And I should have marked on all those that we are working with degrees. Okay? Now what this has done for us over on the right is all of those trig values are ones that we know. Okay, because I've related 15 degrees back to a difference of 45 and 30, and using the formula, I've now got it as 4 trig functions that I can get exact values for. For example, the sine of 45 degrees is the square root of 2 over 2. Cosine of 30, you could certainly feel free here to refer to a unit circle if you needed to. That's the square root of 3 over 2. Cosine of 45 is square root of 2 over 2, and sine of 30 is a half. Okay, from here all the sine and cosines are gone. It's a matter of simplifying. The first part becomes square root 6 over 4, square root 2 over 4 for the second part. Best and final answer I could give is the exact value of the sine of 15 degrees is the square root of 6 minus the square root of 2 over 4. Okay, so that's a big component that we're trying to do, is to get exact trig values for angles that we otherwise couldn't by just simply relating them back to angles that we know the exact trig values for. I can't, this isn't going to work for every angle. It's just increasing the number of possibilities in terms of angles that I can get exact values for. I'm going to skip over these. Same formulas. The key here is to identify which one you're using. For example, in part A, we're saying that alpha is 50 degrees and beta is 10. Okay. In the previous example, I kind of started with the left side of the formula and then went over to the right. Here you're going vice versa. Okay, so you want to simplify it and find the exact value of that expression, but identify the right formula and then use the right side to jump over to the left. Here's another one I want to get you started on. Notice right here, I'm given a bunch of information. I've got two angles, alpha and beta, and I want to find the cosine of alpha plus beta. Well, I'm going to refer to my formula right away. The sum formula for cosine states that the cosine of the sum of two angles, call them alpha and beta, is the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. Okay. Now you notice here in the instructions, I'm not given the angles for alpha and beta, but I'm given their sine values. The issue I'm going to run into here is I don't know their cosine values. Okay. I do not know their cosine values. But here's what I do have. Okay. Here's what I have. It tells me that alpha is in quadrant number 1. Okay, that's what this little piece of information is saying. Alpha is between 0 and pi over 2 radians. And it tells me, because I know its sine value is 4 over 5, okay, if this is alpha, that means its y-coordinate is 4 and its radius is 5. I don't know x, but I could figure that out. Okay? And remember, cosine of any angle, I'm just going to say in this case of, let's say alpha, it's x over r. So if I could find x, and Pythagorean theorem will help me do it, I could get its cosine value. Now over here, okay, this tells me beta is in quadrant 2, so this whole thing right there, that's beta. Okay, this says that beta has a sine value of 5 over 13. Same thing, if I could find x, I could get its cosine value, because cosine is x over r. Okay, I'll help you out with these. That comes out to be 3. That comes out to be negative 12. Okay, those diagrams allow you to get cosine of alpha and cosine beta, which means you could substitute all those in, and away you go. Okay, see if you can finish that one off. And if you have any questions on that, let's talk more in class. But again, stay focused on the big picture. What we're doing is taking the kind of repertoire of angles that we can evaluate in terms of exact trig values instead of approximations. These formulas, the sine and cosine sum and difference formulas, allow us to increase the number of angles that we can do that for. And that's what we're doing here. All right? Let me know if you have questions. Be sure to ask those in class.